What's up, everyone? I am back with another repair, or this will be a repair attempt. So this is a ThermoFisher thermal cycler, also referred to as a PCR machine. I've done a couple videos on repairing these, and I go into pretty great detail about how they work, what they're for. I'm sure you've heard the term PCR, especially at the height of the COVID pandemic, because they were being used in the test COVID test analysis. They were used in that procedure, and basically they are used to make copies of DNA via the polymerase chain reaction. All right, and so I'm not going to go into detail about that, but we can go into a little bit of detail on how these things work. In order for that polymerase chain reaction, or PCR, to take place, you're basically going to be ramping up that reaction mixture up and down through these temperature cycles. And these units allow you to program, customize these temperature programs, and the main part of the unit is this module here, sometimes referred to as the reaction module or the thermal block, and this is one that I've had for years. So basically this portion is just a giant heat sink, and there will be fans. In this case, they're underneath the unit, which I think is a bit interesting because, you know, the air is going to be getting pulled in through the back. There's a vent in the back, and then it's going to get pulled across these fins. At least that's the idea, but they've got the fins underneath it, which I don't think makes for very efficient heat dissipation, but I could be wrong. I would think better placement would be the fan behind this, and you do see other manufacturers make them more like that, where it'll be the vent, air goes through here, fan pulling the air through, you know, because really these work most efficiently when air is passing through them. All right, not, you know, so anyway, but that is the heatsink. And then you've got the Peltier elements, which is a semiconductor device where basically if you apply a current in one direction, they will heat, and if you reverse the polarity, they will cool. And so that's what this is. And then this is glued to the heatsink because you want maximum thermal transfer, heat transfer. And then glued to the Peltier element, you have this reaction module. This one has 3 separate reaction modules and 3 separate Peltier elements, so you can actually have some control over each section of the reaction module and create a gradient. Sometimes that's helpful for certain applications, and so your PCR tube or plate will go into these holes on the reaction module. Okay, and then you'll see here there's a little slot where you can put an RTD. Normally it's a PT1000, and there's a little spot for a screw because there'll be a metal clip that makes contact with the RTD for maximum heat transfer, so that RTD is getting an accurate representation of the reaction module. All right, so there'll be 3 of those as well. Now you can see these Peltier elements, they're definitely customized. This is not a common shape. This little cutout here, and that is so that makes room for the RTD and the screw. So these were definitely made custom for this particular PCR machine. So the problem that we're faced with this guy is one of these Peltier elements has become faulty. And we're going to power this guy on, and I'll show you what the error message is. What I'd like to do, what I'll make this video about, is repairing one of these. I've never tried this before. If you've seen my videos, you'll probably hear me harp on the fact that manufacturers of this equipment don't provide the spare parts, and this is definitely the case here. They are not going to provide you these Peltier elements. They wouldn't even provide you this entire assembly. All right, they're not going to give you any of that. This is a unit where they're only going to allow one of their technicians to repair it, and it's going to be costly. It's probably going to be more costly than grabbing one of these used, which you can get for relatively cheap on the used market compared to the cost of this repair. I'd like to try repairing this with Peltier elements that I found on DigiKey and seeing if it works. If it does, that'll be awesome. If not, I'll have only wasted 300 bucks. So that's the plan. But let me show you this error message, and then we'll kind of get into the actual repair. All right, so this was the error message that the end user got. It says thermal block is not heated up, and this is for board 1, which indicates it's probably for zone 1. And after I removed the block and tested the Peltier element, and there is a quick test you can do. You know, if you take the resistance across one of these Peltier elements, it should be low under ambient temperature. You know, and it could be plus or minus a few ohms. That's what it should be. This one was reading close to 1 kilo ohm, which definitely is a problem. And so something went wrong with these. Now these are pretty old, these units. So, you know, they are starting to age out and have problems. And so that was what prompted this whole repair. Alright, so I'm currently prepping the thermal block or the reaction module to adhere these 3 Peltier elements onto the heatsink. Now, I've done this before with one of these, and I've tried a few different adhesives. This is what I used to use. And it's a great epoxy, it holds really well. The problem is though, it's really thick and viscous. So it's really hard to get an even spread on it. It also dries really quickly, making it kind of difficult to work with. But of course that also has its advantages too. So I'm not using this time. Because what'll happen is it'll start to affect how quickly this thing can dissipate heat and how fast it can warm up, which is a problem. It could cause the errors, and it'll definitely cause your run to be longer. So I'm switching to this, giving this a try instead. So this is more of a paste similar to, you know, what you might find on any type of heatsink on a circuit board. We're going to give this a try. It also seems like this, on the originals, they're using something more like this consistency. I was just concerned about how well it could adhere the elements to the heatsink, but this is what I'm going to try. Now there is a problem, so I'm going to put just link what type of element. This is the closest thing that I could find that isn't customized. You can get these on Mauser or DigiKey, and they almost fit perfectly, but they're just, the originals are slightly, they'll fit much better into this into the heatsink in each of these spots. You can see there's some space in between. I'm hoping though that they'll still do what they're supposed to do. This is an original. You can see that it's cracked, but you will notice that in the center it's got this space that's missing, right? The reason there's that space is because this is where the RTD sits. And so there's usually a little clip that will go there, like this. All right, and so there's a clip there that'll hold the RTD in place, and then this will get screwed in, and so that little screw is popping up. So you need that little space there. So we're not going to be able to do that, unfortunately. So I'm actually, for this, I am using that stronger adhesive to hold them in place, to make sure they don't go anywhere, and they will be sandwiched right up against the Peltier element. So we're going to see if this works. That's probably the biggest hurdle to this whole thing, and of course getting the correct size, we'll see how much of an effect that has. But if this works, you have a means to repair these for relatively cheap. These Peltier elements here are like 90 bucks each. All right, so not too bad. But anyway, so I'm gonna let these dry separately. This is still, it hasn't hardened yet, so I'm gonna clamp this down, make sure that they're all adhere to the heatsink as well as possible. We'll allow it to dry, and then we'll start the next phase of gluing the each reaction module, each zone onto each Peltier element, and then we'll test it out and see how it works. Okay, so this is the apparatus that I've got to clamp these Peltier elements down. Just using a plate to provide a surface to sandwich against them, and then these C-clamps as well. I'm going to let this sit overnight. And, obviously I didn't do like a time lapse of the process, but really it's pretty straightforward. You just want an even coat of the thermal adhesive, not too much, and that's why something that's a little less viscous is easier to provide an even coat as well. And of course this is going to take longer to dry, so I'm letting it sit overnight. And then I've got the actual reaction modules, the RTD, using the stronger epoxy, and gonna let those sit, and then tomorrow we'll place these on the Peltier elements and do the same thing. Alright, so here we go. This is after the thermal glue has dried overnight. It's no longer, tacky. So it's dried all the way. And so now, like I said, it's time to put the reaction modules on. And they're just going to go on top, like so. And I mean, yeah, these do pretty much cover almost the entire surface area, the bottom. So these should work. I think we'll still get uniform temperature, but who knows? I've never tried this before. Alright, so we've got each zone's reaction module glued to each Peltier element, and again repeating the same process, clamping it down. We're going to let it sit overnight. Now one thing you're going to want to do if you're replicating this exactly is you're going to want to ensure that each reaction module is spaced out the correct amount. And so the way you can do that is there is a black rubber gasket that goes in between, it fits through the grooves and then goes around the outer edge. You're going to want to put that on. That's what I'm doing now, at least. Should have showed this first, but you're going to want to make sure that's on there so that they're spaced apart correctly, and that's what I would do. Also, got a multimeter hooked up to one of these new Peltier elements, and you can see, look how low the resistance is, and that's one way you can check to see if these are in good condition. Be a good idea before you glue these on just to make sure each of the RTDs is measuring properly, and so I did that as well. These are PT1000 RTDs, so they should be roughly, well, 1000 ohms is at 0 degrees Celsius, and we're at roughly 20 degrees Celsius here at room temp, so they're going to be a little bit higher than that. So that's another thing you can check for. But again, I'm just going to let this sit overnight, and we'll be able to do the full test in the morning. Okay, we are starting to make some progress. So it took a lot of finagling to get it to this point. For one, I had the polarity of the Peltier elements reversed. And then, so for two of these three reaction modules, it's very easy when you're taking these apart or fiddling around with them to accidentally rip the RTD wire leads off the RTD. They're very easy to accidentally do that with. And basically what I'm saying is it's easy to rip those wire leads off just by simply removing the connector from the TEM control modules. So they're very delicate. And when I disassembled this guy, a couple of them got ripped out. So that's no problem. Just replace the RTD sensor. You can buy those anywhere. You need to get a really small and flat one, but you can get them on Mauser. For some reason, there is a slight difference in how they measure temperature. And it took a while for me to correct for that on each module. Zones 1 and 2 have new RTDs, and zone 3 has the original. And I do a video on how you can basically make adjustments by changing the offset shift resistor on the TEM controller. So I'm not going to go into too much detail there, but that's basically what I had to do. We're actually doing pretty well. So this is within plus or minus 0.25 degrees Celsius. That's the spec for this guy. That's what it should be. And I'm just running a simple incubation program at 37C just to see all it would do. Now what I'm going to do next is actually perform the temperature verification test. Basically an accuracy test with this TVK that's built in to the unit, built into the software of this test, and we're going to see how it performs. And if that goes well, we'll move on to the precision test, the non-uniformity test, see how that does. So far it's been a success after some troubleshooting. Also, another good preliminary test that shows we're on the right track. It passes the it passes the self-verification test. Okay, so we are running into a bit of a snag, a bit of a problem. So now I'm running the temperature verification test. And basically that test brings each block up to 85 degrees Celsius and then brings it down to 45 degrees Celsius, and it's just checking the accuracy. So it's going to compare the values we get with our digital temperature thermometer, which has 9 channels, and it's going to compare this reading against what the instrument is reading, and it should be within plus or minus 0.25 degrees Celsius, but we are only getting up to 85 degrees Celsius. All right, roughly 70, which is a problem. So this is zone 1. Zone 2 is roughly the same. And then for zone 3, it's basically normal. And this is what I was observing when I was just checking it via the incubation run with them at 37C. I thought by, again, adjusting the offset shift resistor value, that I got them all reading 37 degrees Celsius, as I showed you earlier. But as you extrapolate that up to higher temperatures, it's clearly not the same slope as zone 3 for some reason. I'm already thinking that the RTD is what's causing this problem. It clearly works with the original RTD. I mean, that's fantastic. The Peltier element is working. We're proving that with zone 3, but these other two, for some reason, now this is the probe that I bought, and you know, there are a lot of metrics here that you need to be mindful of. Operating supply current, I'm not sure how that could affect, you know, I have no idea what the operating supply current is for this instrument. I suppose we could calculate that or measure it, but yeah, so this is what I bought. I'm thinking of buying, I think I've gotten these in the past, because I've replaced these before for similar reasons, and I believe this is what I bought, but this was years ago. I need to go back and check. I think this is what I got, and it does have a different operating current. So this might be the problem, unfortunately, which means I'll have to disassemble it, re-glue it, all of that, but these are a dime a dozen. They're not that expensive, and if the Peltier elements are working, it's worth it. Alright, so I just did a very crude measurement. Basically, at close to ambient temperature, I'm measuring roughly 0.6, 600 millivolts across the new RTDs, and factor in the resistance at ambient temperature. We're looking at roughly 500 microamps, which, again, this guy is 300 microamps, so maybe that's our problem. That was an oversight on my part. I should have measured that before buying them, but yeah, so I think these are our problem. And so I'm gonna order some different ones, and we're gonna do this all over again. Alright, so we got the replacement RTDs in. So they are glued on to the reaction modules. These are a little bit of a pain to solder. You know, it's difficult, at least it's difficult for me to find a way to hold this little RTD in place and solder those little leads on, and then getting them to stay in the little reservoir, or I mean the little, you know, indent in the reaction module without the clip is a little difficult. And I was thinking of using the clip there just to hold it while it dried, but then I was afraid, well, you know, if you're not careful, the clip itself could get glued onto the RTD, and then when you remove it, lift it back up. But anyway, this is what I found to work. It's just kind of holding the RTD in place, because it will move unless you're using a quick drying adhesive, which you could also use. So just kind of propping the wiring up in just the right spot so it stays flat. That worked. And so now we can move forward. I did check the resistance of these, and they are much more similar to the originals, and I do think it's because of the operating current being the other ones I was using were for an operating current of 300 microamps and not 500 microamps. I really think that was the issue. So I think we should see accurate temperatures with these. Uniformity, hopefully, if we get all the glue done right, but let's move forward. And then what else I'm going to do, instead of kind of clamping things together, you have a clamp right here actually with the instrument itself. So that's actually what I'm going to do instead, because another thing that happened when I did it the first time is the reaction modules and the Peltier elements, they were slightly askew. I didn't get it perfect. And then with this way, I'm just going to do them all together, and then I will clamp it down by screwing this guy back onto it, and then that'll hold it perfectly in place. All right. Okay, so when it comes to applying this adhesive, this is about as thin as I'm going, and you want it to be as uniform as possible. You don't want any clumps, so try to get it as uniform as possible. Don't apply too much, and I just wanted to give you an example of that. And we got the others down, and then we'll do the reaction modules on top. All right, so we basically have the thing clamped down. I mean, this is being held down by the the paneling, and so I'm just going to leave it like this for at least 24 hours, and then when that's done, we'll unscrew it. We'll reconnect all the wiring, any other additional screws that need to be tightened, and then we'll test it again. But I think this will be a lot more effective than the initial um, clamping that I had done prior. So, but we'll see. And one quick thing would be now would be a good time once you have everything just before the glue dries, just double check the RTDs, make sure nothing is shorted, because again with one, um, even with the clamps to solder these new wires in, you really got to be careful when you're getting them in that groove just to make sure they're not connecting. It's probably a good idea. Like what I did is I made sure there was enough thermal glue between the wiring just to make sure that there's no chance of them touching. And then of course you don't want them touching the thermal block or the reaction modules either. So, but as you can see, I've checked all three of them, but this is just an example of one. And again, if you were to measure the originals, they would come very close to this at ambient temperature. So looking good so far. All right, so this is the 24 hours later after rebuilding the thermal block and allowing the thermal glue to dry. And right now I'm just running a quick incubation program which just sets the block every zone at 37C, as you can see. And I've got the TBK set up here. I think it's on zone number 3, and look at that, it's a little bit out of spec, but that we can work with. We can tweak that with the offset shift resistor. But what's promising here, unlike when we tried this before, is if I check each block, this one's a little bit higher, but again, nothing that we couldn't potentially fix. And again, look at that uniformity, it's low, which is great. And then finally, here we are at block number 1. And again, that is looking promising. So what I'd like to try next is to start the temperature verification test, which will check for the accuracy of the block. Obviously we know it's probably going to fail, but I really want to check, make sure the uniformity is looking good. That's more what I'm concerned about across each zone, and then we can run the non-uniformity test as well, just to make sure that's passing. If that passes, I think we're in the clear, and we just need to play with the offset shift resistor values, and then I think we'll be good. Alright, so here are the results of the temperature verification test, and you can see zones 2 and 3 failed, but we can resolve these with the offset shift resistor values, playing with that. But I'm going to do the non-uniformity test now. Alright, so this is the non-uniformity test, and all the zones passed, but overall it's failing. Now it needs to be within 0.5 degrees Celsius. This, however, though, isn't too surprising. I mean, I know for a fact some of the zones are failing for, they're out of spec for temperature, right? And they're out of spec by a pretty good amount. And so if it's looking across the block, one zone is averaging lower than the other, then yeah, you're going to see non-uniformity, which we can fix with the, again, adjusting those that offset shift resistor value, which is what we're going to do next. And then we'll repeat these tests, and if everything looks good, we're I want to say in the clear, but obviously we're going to want to do a bit more in-house testing with this instrument, probably run some samples, see if we can get some data with it. But for the purposes of it, performance-wise, passing with the tools that ThermoFisher uses to validate this instrument, it's doing pretty well. It'll be doing pretty well. So let's do that next, and we'll see how things go. Okay, so I've done an in-depth video on this topic already, but this is basically what I am doing to bring these other zones, zone 2 and 3, into spec. And that is by adding an offset shift resistor, or, well, there is already one there, but adjusting its value by putting a resistor in parallel with it. And so to do that, we're taking in this case, it's a 4.7 mega ohm resistor, and it's being connected to one of the RTD pins, and it's important that it be that one. And then the other leg of this resistor connects to R38, which is a 5K resistor. And so this is effectively bringing that resistance down by maybe, I forget how much, maybe like 5 ohms or so, and that will just bring the temperature down of that zone just by a tiny bit. We're looking at tenths of a degree, not a full degree, so we really only want to change that resistor by a tiny bit. Now, it's unknown how ThermoFisher would make a calibration like this. You know, if they can interface with the microcontroller on the thermoelectric module controller like this one, or if they could do it by interfacing with the main board microprocessor. I'm not sure how they would do it, if they can do it, but because we don't have the ability to do that, this is the quickest thing that you can do. So that's what we're going to try. So I've done that for this zone. I've done that for another zone. Zone number 1 was in spec, so we don't have to touch that one. And we're going to give this a try and see how it works. All right, so this is after the adjusting those shift resistor values for zones 2 and 3, and you can see, I mean, check that out, pretty much bang on. And I believe now we should see the overall non-uniformity test pass as well. So let's run that one next. Alright, so this is the results of the non-uniformity test, and everything has passed, which is great. So as I suspected, once we got all those the temperature accuracy all well within each zone, they would all fall into line. Of course they did. So this is fantastic. Well guys, that is a wrap. As you can see, self-verification test, it passes. I mean, but it was probably clear that was going to happen based on the results of the TVK test that we did. There is one more test that you would be probably good to do, and just it would give you an idea of how quickly how efficiently it's ramping up temperature. Now, there's no specs for this. There's no official test for it, but if you go, let me see. Yeah, if you verify the cycle performance, it'll give you figures for the ramp up time, and that could be helpful to view, and just compare it to some of your other unadulterated SimpliAmp PCRs. But and I think I'll do that as well. And again, we'll do some additional testing with some actual samples, make sure that everything is good. But this is proof right here that it looks like you can repair these with off-the-shelf parts. And again, 3 Peltier elements came to like 270 bucks. Then the RTDs, which you technically really wouldn't have to replace depending on how well you disassemble the thing, but they're also not expensive. They're a couple bucks a piece, and I'm going to drop those part numbers in the video description so that you have them. And I think the most critical part about doing this is just the amount of glue that you use, making sure that you've cleaned the surfaces really well. and proper placement of them. This worked great using this guy actually as your clamp and holding it there. Definitely better than what I tried initially, but I guess I put the wrong sensors in for a reason. Who knows? But yeah, again, and 500 microamp RTDs is what you want. But again, I'll put those parts in the description. I hope you guys found this interesting. I hope you guys found this helpful. This model, and this is going to be true of a lot of the manufacturers of these, they're not going to give you the Peltier elements to repair one of these. They're not. You'd be lucky if they sent you even the whole reaction module. This is going to be a product that either they're going to try to get you to buy a new one, or they're going to charge you an ungodly amount to repair it. You're going to have to send it out to their depot. They're not going to likely do an on-site repair. So all these things get factored into that, making this almost an not it making it it doesn't make it an economical repair to go through the manufacturer. But if you were to do it this way, oh, it's definitely worth saving. You can get these used for under $1,000, depending on what model you want. But I mean, even factoring that in, you got brand new elements. I mean, it's a no-brainer, I think. But anyway, I hope you guys found that interesting. Please leave any feedback in the comments, as always. And if you guys have any requests as far as what type of equipment you'd like to see me attempt to repair, or anything like that, as far as biotech equipment, yeah, put it in the comments. But I'll catch you at the next repair. All right.